Hello, everybody. Nice to see you again in November. This is our office hour in November from Redpanda. And I think this month will be very exciting because we have Donald here. He is going to be live coding and that is guiding us through how to build a real-time gaming leaderboard. I'm super excited, love to see everybody coming in. And I do encourage you to have your questions out, like if you have any questions or any comments or anything that you want to see more, if you want Donna to, do more explanations of what he's trying to do, just let us know, put that in chat. And yeah, so hi everybody. I am Christina. I'm currently based in Boston. Where are you from? Let us know. In the chat, love to see and engage with you. All right, so without further ado, I want to introduce you to Donald Danishka. He is our developer advocate in Redpanda. He's done a bunch of really nice demos for us throughout his times in Redpanda. I'm super excited to have him here. So why don't you take it away, Donald?
Thanks, Christina, and thanks for having me today. Yeah, let's get started. Right, and I welcome you all, and hope we have a good session.
By the way, where are you right now, Donald? Let us know.
I'm joining from the UK, specifically Manchester. So yeah,
Perfect.
nice to see you all.
Let's get the hang of the time zone. But oh, awesome.
It's not too bad. So it's not too bad. Yeah. All right. Shall we go ahead and start?
Let's go ahead and start.
Yeah.
Okay. Tell us a little bit about your scenario for today. Do you want to quickly go over what are we
Oh,
going
yes. Yes, so first of all, let me introduce briefly into what does it mean by a leaderboard? Because we have seen leaderboards everywhere, right? Fitness, gaming, online gaming, and etc. So technically speaking, a leaderboard is a simple two-column table, right? So it has players and the scores in the other side. So it's just two columns, and you might be wondering how easy that would that be to render that on a dashboard. But in order to get there, it's a difficult process because this table has to be sorted and the player scores has to be aggregated, slice and dice to get there. So it's a bit of a hike. So there are three challenges ahead of us: the concurrency, the freshness of data, and the performance of query latency. So these are the three challenges we are trying to solve today and after building this dashboard. So having said that, to build that solution, I have this several components, including Redpanda, ClickHouse, Streamlit, and Python. So our first order of business is to spin up a single node Redpanda cluster with Docker Compose. So this cluster will hold all the raw gameplay events coming from all the concurrently connected gamers. So that's the first order of business. And then secondly, I create a Python script. In fact, this is pre-created, a bit of a cheating, but this is so just to save time. So I have a Python script. So this will simulate 20 gamers connected online, and they will randomly put records into their scores. And then interesting part is
Is there a
bring
reason
it.
why we're putting Redpanda in the middle in order to do that? Because I think a lot of the gaming industries and all that, they would receive things, but to put it together, why is there a good idea to have Redpanda in the middle to intercept these? Is there a reason
Yeah,
why we
yeah, that's a good question, Krishna, because we need to decouple these event producers and the backend, or that is our ClickHouse. Because if the backend goes down, we need to have some sort of a component to hold or buffer our events, and so that we can facilitate more scalability in the future. So that's why we bring in Redpanda.
I
All
see
right.
it's all about scalability, right? Because now like games, they all run in multinational places. So you want to get everybody into a single leaderboard. That's the problem. Yeah, exactly. I see one. Thanks.
Absolutely. Yeah, no problem. And so we were talking at ClickHouse. This is our real-time OLAP database for those who are new to ClickHouse. So the good feature of ClickHouse is that it's good for building this kind of user-facing analytical workloads because, like I mentioned in the beginning, these queries are not trivial primary key-based lookups. They are complicated queries with lots of aggregations and filtering and ordering as well. So in order to do that with hundreds and thousands of concurrency levels, with that much of users connected online, the underlying database must be able to deliver query results within millisecond latency. So ClickHouse is a good choice, ideal choice for building stuff like that. So that's why we bring in ClickHouse to the picture. And ClickHouse has this storage engine called Kafka-backed storage engine, which can ingest even from Redpanda, and it can create a materialized view so that we can have our aggregations running in the materialized view. And then finally, we bring in Streamlit. This is the icing on the cake. So this is our visual component, Python framework for those who are new here. So we can use Streamlit to build our leaderboard front end. And then finally, we'll get to this kind of setup. It's nothing fancy, no animations or anything, but this will cover the essentials here, nuts and bolts. So it's up to you to build your solution on top of this to meet your needs. And then the good news is we have the completed solution at your disposal. So you can always access this GitHub repo. And you can also use I think you can see that in the chat as well.
Yes, we will be a recording of this office hour later in the week in our YouTube channel. So if you're interested to rewatch everything that Donald did again, you just go ahead and go to subscribe to our YouTube channel, and all the code and related link will also be there as well.
Brilliant. And before we get our hands dirty, so we have some prerequisites to meet. So make sure you have these. If you're following along with me, just make sure you have Docker daemon running in your system. So for example, I'm running on a Mac. So this can be run on a Windows or Linux environment as well. So make sure you have Docker desktop and Docker Compose installed, and you have Python 3, version 3 available. That's because of our Python scripts and Streamlit dependency. And then you need a terminal and a browser. That's all we need. All right, let's get cracking. Okay. I'm gonna switch to my terminal. All right, so in fact, I have cloned my Git repo that I mentioned. So you can see two different folders. There's a completed solution in the completed directory, and there's a starter. So this is where you should start. So I'm gonna switch into that, and you can see. Let me know if you can see the text on the screen. Let me know if you need the text size need to be bigger, or just give us a ping. Right. So in this directory, we have two Docker Compose files. One is the Compose, the Redpanda and Redpanda console thing, and we have a producer script. So what I'm going to do first is to create a new virtual environment, because I need to isolate this environment and its dependencies from other Python dependencies. So for that, I use Anaconda. So it's, or you can use virtual env Python. It's not mandatory, but I used to do that as a best practice. So let me quickly create a new environment called gaming with Python version. Yes. All right, now I need to activate this environment. Just notice the prompt. So currently I'm in the default environment, and then I'm going to switch to gaming. Now I'm in the gaming environment. All right. Now, before that, now we are done with our Python virtual environment. Now I'm going to switch to my VS Code, my text editor, and I'll walk you through the Docker compose file here. So this is the first Docker compose file that contains two services, Redpanda broker and the Redpanda console. And we have a shared network in between. This is called demo network. So just a quick overview, we have created a volume for Redpanda for just to store its data. And then we have these few configurations pointed. So I'll just quickly highlight the things that matter the most. So internally, we expose Redpanda address as 9092, and externally, this can be reached via 190.92. So keep that in mind. So when internal components like ClickHouse connect to Redpanda, it will use this one because ClickHouse will be on the same network as well. All right, and then we have Redpanda console. I'll give you a grand tour when I get to that point. But for now, just Redpanda console is a web application, web UI that will give you access to your Redpanda cluster. And it is currently exposed on port 8080. All
Yeah,
right,
this
let's
like about Redpanda because you can always start it up with one single Docker file and then it's running, right? So I really like it. So if any of you who wants to try running Redpanda, there's Donald's GitHub repository, and there's also getting started in our documentations. If you wanted to see the latest and get the latest and greatest on getting started, but I think this is a great start. So yeah, please continue, Donald.
Yeah, thanks, Krishna. And we are going to, so since I have two files, I need to specify which file I'm going to run. So I'm going to run this one up. Right, perfect. So we can do some checking, see whether it's running. All right, so just to make sure we have Redpanda running, so I'm going to switch to Redpanda console. Let me show you how to do that. So this is what you see in Redpanda console. Like I said, this is a web UI, web-based UI that gives you the access to your Redpanda cluster. With here, you can see your health information and configuration parameters applied to your cluster, like the partitions, topics, and you can also access to the bundled components that comes with Redpanda, especially schema registry. So there's no need of deploying schema registry in separate environment. This is already bundled. And you can also see consumer groups, security policies, ACLs, and also the connectors. I haven't configured this one, but if you have any Kafka Connect connectors, source and sink connectors, you can deploy there. We are not going to use connectors here today, but just keep that in mind. All right, now we have our cluster up and running. I'm going to create a new topic to hold our gameplay events. I'm going to use the RPK tool. I'm going to log into Redpanda container.
So I think this is a great way of using it if you're running a Windows machine, right? Because RPK is a tooling that you can also download locally into your local environment. You can use that to connect directly to the Redpanda cluster that you're running. So you don't have to access the RPK tooling from the Docker image. But if you're using Windows machines, you can use this type of way to start executing or running things or playing with other toolings. Using running it inside your Docker image. So that also works as well.
Absolutely, Christian. Let's say game plays. All right. Now the topic has been created. So I just created it with just one partition, but in reality, if you are doing this kind of workload, you might need a different number of partitions, like 30 or 50. It depends on your ingestion throughput. Just keep that in mind. And then what we're going to do is
Number of just kind of a quick reminder, like I think it's about the number of consumers you're gonna have. So I think it's kind of related to that. So when you're trying to deploy a topic, when you're deciding on the petitions, it's mostly related to number of consumer that they're trying to consume, right? And how busy that's going to be, right? So the busier it's going to be, the more you want to set for your petitions. That's kind of the rules, but don't overset it. I've seen some crazy numbers, but don't do that, please.
Absolutely, that's a good addition, Christina. Thanks for bringing that up. All right, now we are done with the first stage. Now our cluster is up and running, and we have a gameplays event topic there. Now let's publish some data into it. In order to do that, I'll quickly walk you through the handy Python script I just wrote. So in fact, I'm not going to live code this because this is a minor concern. I just want to have some data in the cluster. So, you can, so basically this Python script uses this Kafka Python dependency, and then it connects to Redpanda cluster. You can see it's not deployed in Docker Compose. It's connecting from the host machine. So you can see the externally exposed port 190.92, and the topic is gameplays. So it has 20 player names currently. I'm going to switch, randomize, and randomly produce some scores into this. So, right.
What libraries are you using in order to connect to Kafka for the Python?
Good question, Krishna. It's Kafka Python. So that's why we need to, so let's try to run this. It throws you an error because there's no module called Kafka. So since we are in a fresh, brand new environment, we need to install this Kafka Python. So I purposefully made that error. So we can do this. Install this library by pip install. By the way, if you are not new to Python, pip it's sort of a package manager. So it can fetch and install different Python dependencies from its central repository. The library we are going to have today is Kafka Python. With Kafka Python, this is like sort of a SDK that connects to your Kafka or Redpanda APIs from your Python application. Now we should be able to.
I can use any client libraries to.
Absolutely. Yeah. So. And you can even use the REST API as well. It doesn't matter. So since Redpanda and Kafka has identical API interfaces, you can bring in your own your existing Kafka interfaces as well, clients as well. All right, now it's I have started the producing process. Let's switch back to Panda cluster and see how we are doing in terms of data ingestion. I can see data. Right. So this is where you can see your topics. So you can see metadata like partitions, replicas, etc. And if I zoom into gameplays, I can see data is already coming in. You can see the offset is increasing as the time goes by. And the nice thing that Redpanda console provides you is that you can see your actual message payload like this. So this is especially helpful for developers when you are debugging or developing your application. You can actually see your message payload. So just to give you an idea, so in an individual gameplay event, we have a random, unique event ID, and the ID of the game, currently it's fixed, and the name of the player, currently it's, and created the timestamp and the score. This is a very simple JSON formatted event. All right, now what we are going to do now is to bring up ClickHouse to the mix. So in order to do that, I'm going to create a new tab. I'll leave it running here. Okay, the produce is already running. I'm on a new tab, and I'm gonna activate my environment again. And then, okay, and then cd. All right. Before I bring in ClickHouse, just wanted to give you an overview of the ClickHouse Docker file I want to show you. So ClickHouse has different deployment options, Christina. So it can be deployed in Docker, Kubernetes, or it has its own cloud offering. So just for the sake of demo, for this demo, I'm going to bring in a Docker Compose installation. So I just wanted to have these things in two different files so that we can reuse the same network here. So I'm going to use the demo network. So ClickHouse and Redpanda knows they will know each other and they can talk to each other with this network. So here I bring in the ClickHouse server image, Docker image, and I do this bind mount to this local directory. This is to store the ClickHouse data. And then I expose two ports to the outside, port 9000, and this is the wire protocol exposed by ClickHouse. And just to make sure that my ClickHouse is wire compatible with MySQL wire protocol, that means you can connect to your ClickHouse from your MySQL client as well. And then 181.83, this is for the console or playground. Right, let's bring that as well.
Screen, easier to see.
Yeah. Right, there's some, I think this warning is about something not related to us. It should be fine. All right. So how do we make sure that we have ClickHouse is running? So in order to do that, there's this nice web UI comes with ClickHouse installation. This is called the playground. So basically, this is a simple UI to ClickHouse where you can connect and you can issue connect queries, SQL queries to ClickHouse. So I
When
just
you talking about SQL, right? So when you were explaining about the architecture of this demo, like you have, people's score coming into Redpanda, and then you have ClickHouse to kind of doing the OLAP, right? So
yes.
what about like Flink, right? Because I was thinking like I can do the similar things with Flink and then with ClickHouse, right? So I think you can also do that too. But with Flink, with ClickHouse, I think it's a little bit easier because you're doing more like analytic processing, right? So you can do the materialized view. Is that why you choose this solution? I'm just kind of curious, like what's the design decisions behind that?
Yes, in fact, that's a great point again, Christina. So in fact, you can do the same thing with Flink, but uh, with if you are doing that with Flink, you can do the aggregations and materializations as well. But at the end, you have to write the aggregated result into a serving layer, something like a document store or a cache or something like, again, into a ClickHouse maybe. But having Flink is sometimes essential because you need to do a lot of massaging of these events. Probably you need to join these player events with player profiles, and then you can have additional attributes going down to the serving layer so that you can enrich the payload. But today we are not going to do that part, but ClickHouse is also capable of directly ingesting from streaming data source, something like Kafka. And it can do this materialization inside, and it can serve queries faster than the Flink's internal storage. So we can, that's why we use ClickHouse today for this as the serving layer.
That's a great answer, because I think I was just trying to understand what are the different design decisions when it comes to, choosing the right layer for providing like results, right? So I think what you did is pretty good. So thank you for answering that questions.
No problem. But if there's a need for you to join or do some sort of a window processing at the middle, you should definitely bring in additional stream processor like Flink into the mix. Because stream processors are better at doing that than streaming databases like ClickHouse, right?
Oh, so how does how does ClickHouse know about Redpanda then? Like how do they connect together? Would you like to tell us a little bit about it?
Oh, yes, yes. So I'll get to that part in a few seconds. So let me first create a database to hold our stuff. Then I'll bring in the exact configuration. Then I can walk you through the storage requirements. Like I said, ClickHouse is wire compatible with MySQL. That means we can use the same MySQL dialect to work with ClickHouse. That's an absolute beauty. So we don't have to reinvent the wheel here.
Can you make the font size a little bit bigger?
Oh,
So
sure.
thank you.
Is it
Thank you.
better? All right. All right. So if I'm not using this playground, you can use your MySQL command line interface, CLI, for these things, right? And then we can see whether we have our database, regular MySQL queries. Yeah, it has been created. Ooh.
I love this
And then, yeah,
interface. It reminds me of the old SQL days. I've been writing SQLs and all the store procedures. You know that?
exactly.
Of all
If this is not being used today, I would go with MySQL Workbench and connect it to ClickHouse. So good old days. Yeah. And then just to answer your question, so we are now going to create a table in ClickHouse to connect to our gameplay topic in Redpanda and consume from there. So the exact configuration you can see in this ClickHouse file. So what I'm going to do is, so this is available in your completed solution, but I'm too lazy to type everything. So I'm going to do this.
So basically, you're just defining a table and then letting it know where it's coming from, right?
Exactly. So basically, if you compare, so here I'm just creating a table in ClickHouse with the name scores row. So this is going to be row events, and it will have the basic look and shape of the events you see in Redpanda console, in Redpanda actually. So you see event ID, in Redpanda we have event ID, game ID, player, created, and score. And I'm going to map these into the same format in this row table, right? And then I have to set the storage engine as Kafka here because this is going to be a special storage engine. In ClickHouse, you have the option to choose different types of storage engine, merge, and there are sort of things. But for now, we'll use Kafka because we can consume from a log and get the data going. So we have to specify these metadata settings. This is going to be our address of Kafka. So this is the internal address I have mentioned. Container name is Redpanda. And the topic list, this is our gameplays topic. Format would be JSON. I think at the moment we have support for Arrow and Protobuf as well. And then optionally, consumer group name. Right, let's run this. All right. Now let's see whether we can. Now we have a table in place. Let's see whether we can query from it. All right. So there's an error exception. It says direct select is not allowed. So what's the problem here? this is because these kind of Kafka-backed engines, they can't do backward readings. So they can't do sequential reads. So that means you can't go. So that this is explained in the ClickHouse documentation better than my explanation. So basically, what they do is when it can read a record from the log, the Kafka log partition one time, and it will commit the offset, and then you cannot go back and reread it. So that's why we are going to need a different type of storage table called materialized view in ClickHouse. So this materialized view is like a virtual table. What it does is it reads from this source table, and it will do some sort of a aggregation in the middle, and then we can use this materialized view to access from the front end. So that's why we had this error. And in order to create that materialized view, I use this query here again.
There.
Yeah, I'm trying to switch between the tabs. Sorry.
Yeah, that one. Just click on that one.
Yeah, this.
Click on it. What's going on?
Oh, this Zoom thing.
So looking at the
Right. Yeah, sorry.
looking at the command that you just put in, it feels like what it's trying to do is create this memory cache for caching the streamed result into a materialized table, I guess that's what it's trying to do, right?
Yes, that's right. So I define a material as we call scores view. So engine memory. So this means this is in memory. This is kept in memory and eventually flushed out to the disk, I suppose. And then what I do is I write my query like this. So I do one-on-one copy. That means whenever a record comes to the row table, scores row, I copy that table to this scores view. So that's what I'm going to do. And there's this configuration I have to set and allow direct select. So then you can directly select from this material as well. All right, now let's see some select queries. All right, we have data coming in. Because we have our producer running already, you can see the count is getting increased as well. All right. Now, coming back to our initial diagram, now we have our ClickHouse. Just to recap what we did so far. So we have Redpanda cluster there, and then we have Python script simulating 20 players connected online. And then we have ClickHouse connected to Redpanda consuming events, and we have the materialized view running its aggregations. Right. Now, the final part here is to build the dashboard itself. So let's do that. So this is where the coding begins. Before that, I'm going to use the pip install again because I need to install Streamlit dependency in my system. For those who are new to Streamlit, you can find more information about Streamlit in this Streamlit website. This is more familiar with data professionals, especially with data scientists and data analysts, because these data professionals, they are very familiar with Python, and this is a good framework built on top of Python to work with data sets and visualize them. And you can build interactive dashboards and data applications with that. These can be used in internal applications or you can host them on cloud so that customers can access as well. All right. In order to work with Streamlit, we need to have Streamlit installed in our system. So I'm going to install Streamlit. Might take some time. There's quite a bit of dependencies to fetch.
I guess it's understandable because it's trying to do a lot for analyzing data streams and all that, right?
That's right. And given that this is a fresh environment, so it's like a clean slate. So there's a lot to do. All right. Okay. All right. There we are. Okay. Now what I'm going to do is I'm going to switch to my code editor, and I'm still inside the starter folder. I'm going to create a folder called Streamlit. And then inside this, I'm going to create a Python file called, the name can be anything, but this is like a norm in the Streamlit. So it's called app.py. First thing I need to do is to import the Streamlit dependencies. All right. And then with Streamlit, I can just write down the markup of my user interface. So what I'm going to do first is to create a title. Let's say Redpanda demo. And just save this file and let's try to run it. We are not done yet, but I'll show you how to run this. So in order to run this, let's see where we are right now. So we are in the root directory, and I'm gonna go to inside Streamlit. You can see app.py. In order to run it, Streamlit run. Might take a bit of time because this is the very first time. And then once you are done, you should print out the URL of your dashboard. So what it does is, it will open a new browser tab. This is like a web server, embedded web server. So it has the
CLI that you need to install, the Streamlit CLI, or is it within the Python? Oh, perfect. It's running.
Yes, it's in Python.
Okay.
So, all right, now we can see Redpanda demo. The nice thing about Streamlit is, so this is, you can see your changes as you make them. So for example, if I make a divider here, just want to do this file fancy thing. And I just save the file, go back to browser, and Streamlit tells me that the source file has been changed because it tracks the changes. And this is good for iterative development. I can just rerun and you can see the dependent. All right. Now we have our platform ready to start coding on the leaderboard. And I'll quickly connect this one. First thing is, now we have a running dashboard. The first question is, how can we connect to ClickHouse from this? For that, we need a driver, sort of provided by ClickHouse. So it's called ClickHouse Connect. So I'm going to install that in my environment as well. So I have this issue with this terminal, so it basically goes back to my default environment. So I'm going to activate gaming. There we go. All right. So what I need is pip install ClickHouse Connect. So this is basically the Python driver for ClickHouse. So with that, you can connect to ClickHouse from your Python application. All right. Okay. Then I need to import this dependency here. Then let's write some code. So basically, this is where I specify my connection parameters. So basically, I have to specify the host of the ClickHouse server.
Localhost.
Yes. So
It's an L in your host name.
yeah, so basically, it's supposed to, for some reason, so it binds to localhost in ClickHouse container. For some reason, still need to figure out.
But I mean, like, you misspell your localhost. That's what I meant.
Oh, right. Oh, sorry. Thanks for catching that. All right. Then the port is this one. You remember we exposed this port. And then the username, we'll be using the default.
That's how you would normally connect to a database, right? Just
Yes.
specify ports where the hosts are and then the login credentials.
That's pretty much basic stuff we are doing here.
Right.
So this is the usual default login credentials I'm using here. Right. And then I need to write a simple query first. Let's do a simple query first, and then we'll do the aggregation later, just to make sure everything works nice and tight from end to end.
So we're selecting from the materialized view that you just created, right?
That's right. I'm gonna just get the first 10 records. And then I'm going to use the client to submit the query to ClickHouse server. And then this client has a nice feature called get DEF method, where this can return a pandas data frame as the result. So that means it reads the result set from ClickHouse and it transforms it to a pandas data frame, which is more popular among data professionals, and it returns the program. All right, and then we need a variable to hold it. All right, now we have data at hand. We can tell Streamlit to print this on a HTML table. That's easy than we thought, because you can directly pass this pandas data frame inside. And then I'm using some configurations to make it more clear and pretty when it comes to rendering. And then
so these are all rendering parameters, right?
That's right. So basically, I'm instructing Streamlit to use the full width of the container when displaying, and then with this parameter, and then so Streamlit typically use this zero base index when it displays a data frame. So I'm gonna tell them you don't show that. Just turn it off.
Simple enough, right? Like it feels very simple, very self-explanatory. You connect to the streaming database, and then you put in the queries, and then you're trying to print out the result of the query. It feels like very like that.
Thanks. And let's see whether this works. Did we shut? Oh, right. This is still running, so that means if we switch here, I think we have to restart because we have installed this dependency, but it doesn't matter. All right. I think I made a typo. Live coding. Would be fine. All right. So you can see this is the simplest. This is not the final query. This is just a select all and limit 10. So this is just a simple, and this confirms that we have end-to-end solution running. Now, the final stage is we need to write the actual aggregation query to get uh, the results we expect in the dashboard. So I can edit this query here. So what we need to do is I'm querying the material as view, and I need to read the player, and then I need to sum the score. This is going to be an aggregation total, and this is going to be my projection, and these are the only two columns I need to show in the leaderboard, and then there will be a group by player, because you see several, we have to group by the player and aggregate because there can be different uh, scores, multiple scores for same player. And I'm going to sort it because otherwise we can't see the top one. Order by total and descending order. This is pretty much typical SQL, right? So nothing to worry about. And then I need to limit this to just say 10 players. All right. Ideally, if we refresh, it work. Yes.
Wow.
So here we
So it's
go. Yes.
directly
And
from the stream. And then oh, this is really cool.
yeah, and if we refresh, we can see few data coming. So how much time we have? I think I think
We're almost out of time. Well, we're out of time. This is a 45-minute session, but that's fine. Let's just finish this one. Just let us just guide us through the entire demo, and then we can do
sure,
it.
sure, Christian. I think I'm almost done. So just the last, the icing on the cake is remaining. So I would say I just wanted to, so this is the bare minimum of the dashboard. I just want to build, but I have the complete solution in the completed directory. So let me go there.
So what does the complete solution looks like?
So it should be, so it should be inside the completed directory. So if you navigate there, completed, you should see there's a folder called Streamlit. So it has everything I have built so far. And the only difference is there's a single Docker Compose file. So it has all the components inside. So if you go to this Git repo, it has a detailed README file. You can follow from top to bottom. And let's give it a try to bring up this final look and feel. All right, you can see a nice panda. And just before that, let me.
So I guess you're running several different queries in that same program, right? So
That's right. That's right. I can walk you through because we are almost at the top of the hour, but I'll just give you a brief overview. So currently, there are three queries, one for the leaderboard, like I wrote earlier, and then there are two other queries. These are the metrics. So this will print the unique number of players currently connected, because I'm simulating 20, currently shows 20, and who are the players actually active in last minute. So basically, they can be viewed, right? So the code for this is here. So this is all Streamlit markup here. You can just go. This is pretty much self-explanatory. So you can read it and have it a go. So yeah, I think Christina, that's it for today.
So
So
this is really good. So thank you for taking us through this very nice demo showing how everything was put together. I think this is a great example of how you can handle a large load of data coming in and trying to analyze them all in a streamlined way, and then to quickly have everything display real time. So I think this is a great example. So thank you very much for everyone for attending this office hours. We're looking forward to see you next time. If you like this type of content, please come and join us next time. Let us know, what your preference is. What kind of content would you like to see next time? Let us know in the Slack community. And if you want to learn more about Redpanda, there is a Redpanda University that has all the course relating to like how to get started with Python. If you have other languages preference, there's always different clients languages available in the university. So yeah, please take a look. Thank you very much, and I will